8.6, the binomial theorem. Okay, so sometimes when we are expanding brackets, honestly, even to the power of 2 can be annoying. When we get to 3 and 4 and higher, it's a lot more work. So what you should notice here is looking at these, you should notice a pattern. So first of all, it makes the Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So if I was to guess on the next one, it's going to start with a 1. And it also goes x, x squared, x cubed, x to the power of 4. So I'm going to guess it's going to go x to the power of 5. Then the next number is going to be a 5. And if you look at our x value, it has gone down 1 since the last one. And it keeps going down 1 until it's gone. And if you look at our y values, it starts at 1, and then it goes to 2, and then it goes to 3, and then it goes to 4, and it keeps getting 1 higher. So that's kind of our pattern. So our x value is going to go down by 1, and our y value is going to go up by 1. So it's to the power of 1. My next number is 10, so it'd be 10. X is going to go down by 1, so 3. Y is going to go up by 1, so 2. My next number is 10 again, so it'd be 10. X to the power of 2. Y to the power of 3. I am recognizing that I'm running out of room. The next number will be 5. We're going backwards now. So 5, we have 1x, and my y is to the power of 4. And our last one would be 1y to the power of 5. So our x's decrease, our y's increase. So let's use this knowledge to expand this. So we have 3b minus 1 to the power of 4. So in Pascal's triangle, sometimes it's useful to just keep one written out, so I'm just going to write one out for us right here. So I realized I probably don't need to go that far. Anyways, so when we are expanding this, what you want to do is whatever this exponent is, that's the row you're going to start with where your number is. So that first number is 4, so I'm going to use this row. So I'm going to start with 1. This is going to count as my first term, so it's going to be 3b to the power of 4. You always start with whatever your exponent is. Now I'm going to write my coefficient of 4. My 3b is now going to go down 1, and my minus 1 is going to be to the power of 1, which you don't have to write. Then we have 6. 3b is going to go down to squared, and negative 1 is going to be squared. Then our next number is 4. So plus 4. 3b is down to a 1, and negative 1 is up to a 3. And our last term is 1, and we have negative 1 to the power of 4. Now we can simplify. Don't forget to distribute that to the power of 4 in. So we have 3 to the power of 4, b to the power of 4, plus 4 times 3 to the power of 3, b to the power of 3, times negative 1. So, yeah, okay. Plus 6 times 3 squared times b squared, and negative 1 squared is 1. Plus 4 times 3 times b times negative 1 cubed, which is negative 1, plus negative 1 to the power of 4 is positive 1. Now you can type these in, so or do them in your head. 3 to the power of 4 is 81, so we have 81b4. If I type in 4 times 3 cubed times negative 1, I'll get 108, that is negative b to the power of 3. 6 times 3 squared times 1 is 54, so we have 54b squared. 4 times 3 times negative 1 is negative 12b, and then we have plus 1. So this is my simplified expanded term. Okay, we're going to simplify this one. So same exact thing. So thinking back to Pascal's triangle. We're doing to the power of 3, so we're going to use this row. So 1, 3, 3, 1. I'm just going to write that down. So this counts as my x term, and this counts as my y term. So I have 1, 4a squared, and then to the power of whatever your exponent is, plus 3. My 4a squared is going to move down to a 2, and 2b is going to come in as a power of 1, plus 3. 4a squared is moving down to 1, 2b is turning into a squared, plus 1, and we'll have 2b to the power of 3. Now we'll distribute, so we have 4 to the power of 3 and a to the power of 6. Remember, 2 times 3 is 6, plus 3 times 4 squared times a to the power of 4 times 2 times b, plus 3 times 4 times a squared, and distribute that 2 in, so 2 squared times b squared, and then last one, distribute that 3 into both, so we have 2 to the power of 3, b to the power of 3. And now we can simplify, so 4 cubed is 64, so we have 64 a to the power of 6. Then we have 3 times 4 squared times 2, and we get 96. And then we have a to the power of 4 and a b. 3 times 4 times 2 squared is going to get me 48. And then we have an a squared and a b squared. And 2 cubed is 8, so we have 8b cubed. So this is my expanded binomial. And that is the binomial theorem, part 1.